doing trigonometry a second day. So trigonometry was those funky functions we worked with last class, the sine, cosine, and tangent. I am not going to be going over again how to use the calculator, so if you didn't understand how to use the calculator, I suggest pausing the video now, going back to my YouTube channel, and rewatching the video there just so you can make sure you understand how to use Desmos, because we are going to be using that every class going forward, and I don't want to waste everyone's time by doing 2 lessons on the same thing. So if you don't remember how to use the calculator, pause the video now, go and briefly watch that part again, and then come on back. All right. So before we can go and really explore sine, cosine, and tangent, it's going to require us to do a little bit of equation solving. So we're going to jump into some good old-fashioned equation solving. So I'm going to give you 2 different equations. We'll start with question 1 right here, which is going to be x over 3 equals 6. What is the value of x for this problem? All right. Well, in order to find this, hopefully what you did, maybe you did it in your head, but what you were doing in your head was you were multiplying both sides by 3 to cancel out the 3 down here and find that x's value is equal to 6 times 3, which is 18. So our value for x in this situation is 18. All right, but now we're going to do a slightly different problem, which is 3 divided by x equals 6. What do you think the answer to this is? Now, this is a slightly different question, so think about it, and then we'll go and explain how it works. Okay, so unlike this last problem we just did, it's not like a simple one-step process. Even though it looks like it should be, there's only one operation happening, it's actually going to take 2 steps to solve this problem. So since the x is in the denominator of our problem, we can't get rid of it by simply taking away the 3 anyway. The 3 is stuck on the top, so we have to get rid of that x first. So what I'm going to do here is I'm first going to multiply both sides by x. By multiplying both sides by x, the x's cancel each other out on this side, leaving us with just the number 3. And 6 times x just becomes 6x. Now this is a good old-fashioned simple problem now. What would my last step be? What would I have to do to find the value of x now? Good, I'd have to divide both sides by 6. Now realizing this is not saying 6 divided by 3, it's saying 3 divided by 6. If you have 3 cookies and 6 friends and want to give each friend some cookie, how many cookies does each person get? What is 3 divided by 6? Good, each person will get half a cookie, so you have 1/2 is equal to x. The difference of where the variable is in a fraction equation solving problem is really important when it comes to some of our trigonometric functions. So we're going to do one more of each. So question 3 and question 4. I'm going to make question 3 5 equals x over 2. And so solve that. Tell me what the value of x is. All right, the value of x here, you would multiply both sides by 2, and you'd get 10 equals x. Good. And then what I'm going to do over here is I'm going to say 3, no, not 3, we just used 3. Let's use 10 equals 2 over x. Solve that, tell me what the value of x is. Good, so we're going to multiply both sides by x. That's what we just did in that last example. We get 10x equals 2 because the x's cancel each other out. And then we're going to divide both sides by 10, giving us x equals, once again, this is going to be a fraction. We're doing 2 divided by 10. 2 cookies, 10 friends. Each person gets how much? 2 divided by 10 is going to reduce to 1/5. And that's going to be our answer for question 4. All right, we are going to need to know that later in today's lesson, so just hold on to that. It's just a quick review of identifying hypotenuse, adjacent, and opposite sides. So I've already indicated this is the angle we're working with, that 50-degree angle. What color is the hypotenuse? what color is the opposite side, what color is the adjacent side to that 50-degree angle. All right, the hypotenuse is blue, the opposite side is red, and the adjacent side is green. It's really important that we're able to identify those three types of sides because they're the building blocks of everything we're going to be moving into today. So, the other thing I want to do with you really quickly is just one really quick Desmos calculation. So, we are going to find I'm going to clear that. We're going to find the cosine of 30 degrees. Just make sure we can type that in. So what is the calculation for the cosine of 30 degrees? Oh, sorry, cosine of, 30 degrees. All right, so we're going to do cosine 30 degrees, close parentheses, and that's your answer right there, 0.866. Now, if you did not get that, pause the video right now, go back and watch my previous video because you're not going to be able to do today's lesson if you didn't get that value. All right, so clear that. So let's move on to the good stuff here. Here are our three trigonometric ratios. These are what I introduced. These are the functions we practiced on the calculator last class, and these are what we're going to be exploring a little bit more in depth. So today we're going to go one by one and kind of learn what the relationship, the ratio is. So we'll start with sine. Sine of an angle is equal to the opposite over the hypotenuse. So what that means is when we find the sine of an angle, let's say I asked you to find the sine of 30 degrees, that number, whatever you would calculate that as, whatever the sine of 30 degrees would be, is going to also be equal to the value of the opposite side divided by its hypotenuse. So sine is equal to opposite over hypotenuse, SOH. Let's look at the next ratio. Cosine of an angle is equal to the adjacent side divided by the hypotenuse. So we would calculate the cosine of a given angle, and we would divide the adjacent side by the hypotenuse, and those should be equal. So that's cosine is equal to adjacent over hypotenuse, or CAH. Moving on to tangent. Tangent of an angle is equal to the opposite side divided by the adjacent side. So if you calculated the tangent of an angle, and then you took the opposite side's value and divided it by the adjacent side value, those two should be the exact same number, and that's TOA. The reason why I'm telling you these letter combinations is because it's really important we remember which sides associate with which trig function. So we have sine opposite over hypotenuse. We have cosine is adjacent over hypotenuse, and tangent is equal to opposite side over the adjacent side. This is a really great time. I know we haven't been taking notes very much in this process, but right now I want you to pause the video, go grab a math notebook, and write this down. Sine is sine of an angle equals opposite over hypotenuse. Cosine is equal to the adjacent side divided by the hypotenuse. Tangent equals opposite side over adjacent side. Now, this is going to be your homework. We have to memorize this organization of letters. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent, which is abbreviated to SOHCAHTOA. I want you, as your homework, so it doesn't need to be done tonight, it just needs to be done before next class, to create a mnemonic device. So you might know Every Good Boy Deserves Fudge from music class. You might know Please Excuse My Dear Aunt Sally for PEMDAS, Order of Operations. Those are all mnemonic devices. I want you to create a mnemonic device that allows you to remember SOHCAHTOA. You can either make one big sentence or make one mnemonic device for sine, another mnemonic device for cosine, and a third mnemonic device for tangent. But that's going to be your homework today. Okay? Now moving on, we still have a little bit more of this lesson to kind of explore what is this, what does it mean, why is it important, but I did want to just introduce it. That's going to be your kind of more fun homework assignment for today. Okay, so now let's explore each individually again. So we said that the sine of an angle is equal to the opposite side over the hypotenuse. Let's prove that to you though. So if I give you a right triangle, and let's say it's a 30, 60, 90 right triangle. So that's 90, and I'm going to say that this is 30 degrees. I'm going to say this side is 5, making the longest side 10. So in this situation, we would use sine because we are given the opposite side and the hypotenuse. So we would have to use sine. So we would plug in each of these values into the equation. The angle goes in to the angle of the equation. So this becomes sine of 30 degrees equals the opposite side of the hypotenuse. So the opposite side is which number, 5 or 10? If the opposite side is 5, the hypotenuse is 10. So if this is right, then the sine of 30 degrees should be equal to 5 divided by 10. Let's check. Let's go to our tab that has Desmos already open. What is the sine of 30 degrees? Find that out for me. Good. Sine of 30 degrees is 0.5. And what do you get when you do 5 divided by 10? Also 0.5. That is not a coincidence. That is the whole purpose of this trigonometric function. That will always happen. The opposite side of an angle and its hypotenuse will always be equal to the sine of that angle. All right, let's see what happens when we move on to a different trig function. All right, let's add a new layer. All right, so let's say I have another, we're going to make another one right there. That's 90 degrees. We'll say this is 60 degrees. This is going to be 6, and this is going to be 12. Now, what types of sides are we dealing with? Are we dealing with opposite, adjacent, hypotenuse? Which two of those three are we dealing with here? If we're looking at this angle 60. Good. We're dealing with an adjacent side and a hypotenuse. Which trig function, remember you had to write it down, that's why I had you write it down in your notes. Which trig function, sine, cosine, or tangent, uses adjacent and hypotenuse? Good. Cosine was adjacent and hypotenuse. So we're going to use cosine. So the function we're going to do now is cosine of our angle is 60 degrees, equals the adjacent side, which we valued at 6, over the hypotenuse, which we valued at 12. Now, 6 divided by 12 is 0.5. If this makes sense, and then cosine of 60 degrees should also be 0.5. So let's check that on Desmos. Cosine, clear my screen. Cosine 60 equals 0.5, or in fraction form, 1/2. So 0.5 once again equals 0.5. And now let's move on to one more. I'm going to give you a right triangle. I'm going to say that this is 45 degrees. This is side length of 12. This also has a side length of 12. If we have been dealing with this 45-degree angle, 12, each of these sides, 12 and 12, are what? Are they adjacent, opposite, or hypotenuse? What two of the three are we dealing with? Hopefully you said opposite and adjacent, because that is what we're dealing with. And now which trig function uses opposite and adjacent, O and A, in their formula? Tangent does. Tangent is equal to opposite over adjacent. So we're going to make an equation using the angle, tangent of the angle 45 degrees equals the opposite side's value, which in this case is 12, the adjacent side's value, which in this case is 12. 12 divided by 12 equals 1. Let's find out what the tangent of 45 is. Go over to Desmos, find the value of tangent of 45. Let's check. Clear. Tangent 45 also equals 1. All right, so I just wanted to show you why those work, but let's actually see what type of math problems we might solve given this information. All right, so now we're going to dive into why we might use these trig functions. So I just showed you that they work, but now let's figure out why we would use them. So here I have a right triangle. I have an angle given, which is 33 degrees. I have a side given, which is 12, and then I have an unknown side, which is x. What sides is 12? If they were dealing with 33 degree, which side is it? The opposite, the hypotenuse, or the adjacent side? So in this situation, 12 is the adjacent side. And what type of side is x representing? X is representing the hypotenuse. So now which trig function will we be able to use that utilizes the adjacent side and the hypotenuse? Good. Adjacent over hypotenuse. So SOHCAHTOA, C-A-H. Depending on what mnemonic device you come up with, that's going to maybe be how you help you remember. But we're going to use cosine, because cosine of the angle is equal to adjacent over hypotenuse. So we're going to plug these in. Cosine of 33 equals the value of the adjacent side over the value of the hypotenuse side, which is right now just represented with x. Now I'm just going to show you how to solve this. I'm not going to have you actually solve them today. We're going to have you solve them tomorrow, or rather next class, so next week. The first thing you'll do is you'll calculate cosine of 33. So you'll go to Desmos. Oh, wrong tab. You'll go to Desmos and you'll calculate what is the cosine of 33 degrees. And you'll round it. It's not going to be a perfectly exact number. It's okay. So we'll round it to the nearest, let's go the nearest thousandth. So the nearest thousandth would be 0.839. Equals 12 over x. And now this is just like those problems we started class with. We're going to multiply both sides by x to get x by itself over here, to get rid of x on the denominator. Then we'll have 0.839 equals 12, x equals 12. And we'll divide both sides by 0.839. It's no different from the problems we did before, except it just has decimals. Then we'll get our value of x as 12 divided by that number. Now I'll show you a cool calculator trick. We already had that number right there. So if I want to enter a new line, I press that blue enter button. And if I wanted to do 12 divided by that previous answer, I'm going to press the answer button that's right between the decimal and the addition symbol. And that answer is going to get preloaded, and that will be our answer, 14.308. That's how long the hypotenuse is. We're going to do just a couple more of those, less so solving. I just wanted to show you how the solving worked. We're going to focus on solving next class, just in terms of picking which trig function to use. So here I have a new right triangle. I'm going to make this side 15. This side is unknown, and we have this angle over here as 27 degrees. Which trig function am I going to use? So in this situation, I have the opposite side, I have the hypotenuse, and if I look back at the notes I wrote down, and now hopefully you're realizing I'm going back to these notes several times, and we're going to continue learning this. So if you didn't go back and write down the notes when I said to earlier today, pause the video, rewind to the place where I told you to take notes, and write that down. It's going to be important. All right, so we have the opposite and the hypotenuse being dealt with here, which means we're going to use sine, because sine deals with opposite and hypotenuse. So I'm just going to set it up. Sine of 27 equals my opposite value, which I have as x, my hypotenuse, which I have as 15, and then we would be able to solve it, but we're not going to do that right now. All right, we're just going to do a few more of those. All right, so now we have a couple problems that you can use to try to determine which we are using. So what I want you to do, this is question 1, question 2, question 3. What trig function should you use for question 1? What trig function should you use for question 2? What trig function should you use for question 3? All right, now let's see how that went. I have my 40-degree angle over here. X is my opposite side. 3 is my adjacent side. For number 2, I have my 70-degree angle over here. 12 is my opposite side, and X is my hypotenuse. And over here, lastly, I have 42 with its adjacent side and 8 as the hypotenuse. Now that I've given you that information, one last question. Is there any of those answers you originally wrote down that you want to change? Question 1, 2, or 3? All right, so for question 1, we have opposite and adjacent there. We're going to use tangent, because tangent is equal to opposite over adjacent. The function would look like tangent of 40 degrees equals x over 3. Question 2, we would have opposite and hypotenuse, which is sine uses opposite. Sine is equal to opposite over hypotenuse. And then that equation would look like sine of 70 degrees equals 12 over x. And lastly, we have adjacent and hypotenuse, which is cosine. Cosine is equal to adjacent over hypotenuse, so we would use cosine in this situation, making the equation cosine of 42 equals x over 8. If you'd like to challenge yourself, try to solve these and see what you get for the value of x. That's about it for today. Remember, you do have a homework assignment though, so you're going to go and now make a mnemonic device. You can make it a drawing if you like. You can just write a silly sentence. I'll have a couple examples on the assignment there. So now that you finish this, go over to Classroom again and create your mnemonic device for SOHCAHTOA, sine of opposite over hypotenuse, cosine of adjacent over hypotenuse, tangent of opposite over adjacent. Something that's going to help that stick in your mind because it's something we're going to be using a lot. Have a great day, guys.